There we go. All right, so you know what I'd like to do? I'd love for you to tell me what we talked about yesterday. I know how to say it, but how about somebody just starting out and Zach, you look like you're ready. Can you just say, hey, tell me something you remember from yesterday? Just see the top part of that handout. See, just kind of talk like you're the teacher, okay?
We talked about chemical symbols.
What are those?
Like the letters up there.
Yes, and what do they represent?
The elements.
Yes, keep going.
We learned about chemical formulas. Represents like compounds.
And we just had a whole chapter on that, didn't we? Go ahead.
Chemical equations. It's like or it represents a chemical reaction. So the equation.
Excellent. You're doing a great job. See that? Now, just saying that should get you more engaged. You get that? Now, so that's the new chapter. The new chapter is chapter 6. And I do ask you to read it. If you just said, I'm going to read about 3 pages a day, or hey, I don't feel like reading one day, I'll read 5 pages every other day. If you could do that, it's a really short chapter. You could read it twice before the test. So, after the lesson, if you start reading it, things will kind of fill in. Some of the gaps will be filled in like that. All right, let's go on. Somebody else start here and tell me what else we did yesterday. Oh man, who could do this? You weren't here. You weren't here. Daniel, start here and tell me some more things we did.
We learned about reactants and products.
What are those?
Reactants are chemicals that react, and then products are chemicals that are produced.
And where would I find those in a chemical equation?
You'd find the reactants on the left side, and you'd usually find the products on the right side.
Okay, and what is it that separates the reactants from the products?
Arrows.
An arrow. What's that arrow mean?
Arrows usually mean like it produces.
It could mean produces, yields, forms, makes. Everybody get that? So, all right, very good. And tell me what you can finish as soon as you tell me what these little things are. What are these little symbols here?
They like represent what the chemical is. Like if it's a salt, if it's S, it's a solid. If it's L, it's a liquid.
Right. So it's what they call. Remember the phases: solid, liquid, gas. Remember that? So what the physical state is, and what does AQ stand for?
Dissolved in water.
Okay. Does everybody know what table salt looks like? Okay, that's called NaClS. I happen to, for my other class, I have a demonstration ready. Here, this is NaClAQ. What does NaClAQ look like? Water. Okay, you see the difference? So NaClS would look like the stuff that comes out of a salt shaker. NaCl aqueous, I won't be able to see it. I won't see it because it's dissolved in water. All right, good job. Now let's go down here, and if I were to write, and this is what I did yesterday, if I were to write an equation like this, and instead of writing zinc, I gave you a piece of Lego piece, okay? And it looked like that. I said 1 zinc plus this Lego, HCl, see that? Could I rearrange that? Could I use this and rearrange it to form the zinc chloride and hydrogen gas? And you said, oh no, you had one of those and you ended up with 2. You can't do that. And you had 1 star and you ended up with 2. You can't do that. So what was wrong with this equation? What's wrong with it? Yes.
You had 2 stars on one side and only 1 on the other.
So it's not what? What's that B word we use? What's the B word? It means you don't have the same number of those on the left as you do on the right. And remember I talked about the bank? I put $1,000 in. You said I spent $800 and I have nothing left. Something's not what? What's that word again? Balanced. So we have to balance an equation, and we do that with coefficients. Now, coefficient says, and this is God. This is the way God works, right? God said, hey, zinc, can you react with 1 HCl? No. God said, no, it's not going to happen. God says, 1 zinc will react with 2 HCl, not 1. And so take a look and see if it works. What if I give you 2 of these things? Could I rearrange these now and make that? And he said, Yeah, that makes a lot of sense now. And that's why we balance an equation, because you can't lose an atom out of nowhere, and you can't get a new one out of nowhere either. All right, and also we have to learn there are some elements, and God made some elements that are just by themselves. Carbon might be by itself, or chromium might be by itself, but he also had a variety of elements that were called diatomic elements. They have elements that, when they're by themselves, there's always two of them together in a compound. Okay, who remembers, let's see, who got calling? You weren't here. Kyle, do you remember the diatomic elements? See if they're in your notes somewhere. That's another thing about taking notes. See if your notes have it on there. Should have been on this page. Probably should have been on page 1. What are the diatomic elements?
Chlorine.
Yes?
Bromine, iodine.
Right, so the enes are all the ones in the halogens: fluorine, chlorine, bromine, iodine, and what else?
That's all I have.
Okay, so here's a little trick for you. It's all the ones who end in gen, whose name ends in gen: oxygen, hydrogen, nitrogen, and the ones that end in ene. So if they end in gen or they end in ene, now here, every year, both classes, people misunderstand what I said. Look at this compound here. This is glucose. That has 6 carbons, and well, you can have as many elements as you want in a compound. But what if you just have the element oxygen? It's going to be O2. Right now, what am I breathing in the air? I'm not breathing O, I'm breathing O2. And what's the other gas? 80% of what you breathe is called nitrogen. That's the element nitrogen, and it's N2. So about 80% when I breathe is N2, and about 20% I breathe is O2. My body doesn't even use the N2. The N2 comes in, the N2 goes out. What's it even is more interesting is about 20% oxygen comes in. How much goes out? Anybody thought about that? That has nothing to do with this chapter, but did you know about 16, I'm sorry, I gave it away. About 20% comes in, and about 16% of my exhale breath has oxygen in it. And that makes sense, because if you're going to do a CPR, what are you breathing into them? Something has no oxygen? No, it has oxygen in it, doesn't it? So anyway, there are diatomic elements. So we have to remember about diatomic elements, and we have to remember that if you're going to balance an equation, you use coefficients. All right, let's go on to the next page. Now, and again, the better you do in this chapter, I would love for you to do the same lab that the other class is doing. It's about a 4-day lab, and you get to go from table to table to table. We do talk about safety, but you're going to be doing some dangerous experiments, and you're going to actually let them react. You're going to let this chemical react with this chemical. You're going to write the chemical equation out, okay? So humans do this all the time. Humans like to put things into categories. For first year chemistry, I have 5 categories for you that all chemical reactions can be put in. Again, this is first year. Look at synthesis. Synthesis means you might take one element and another element and put them together, and they would form a compound, wouldn't they? And we went down here and tried to scan for that. So yesterday you told me number 3 looked like A plus B yields AB, and that was synthesis. Somebody else said number 6, A plus B yields AB. So you were correct on that too. Let me make this a little bit smaller. There you go. All right, then we flip the page over. Everybody flip the page over. Were any of these synthesis? And you told me number 1 was A plus B yields AB. And you told me number 4 was, that was correct. And number 6, that was correct. Okay, then we went back over here, and the next thing we learned was the opposite. What would be the opposite of taking things and building something bigger? And by the way, maybe you never even knew in 9th grade. In the 9th grade, maybe you never understood why they called it photosynthesis. And photosynthesis would be like this one. It'd be like carbon dioxide from the air and water from either the air or the ground in the presence of chlorophyll and light and enzymes can actually do this fantastic thing. In cells that are plant cells, they can actually make the compound C6H12O6, and they also will produce oxygen gas. That is the equation you should have had in the 9th grade. Do you remember it? You remember photosynthesis? So you're taking things that are simple and making them into something more complex. You're synthesizing. You see that? Does everybody know what? Have you ever used the word synthesis besides that? Do you know? Do you know what they call? Do you know what they call elements that are past number 92? You can actually find uranium on the Earth somewhere. Okay, you can find all these elements on the Earth except, and this is weird, except for technetium and promethium. Except for these two, the first 92 elements can be found somewhere on the planet Earth. But where did these come from? These are not found naturally on the Earth. You'll never find them in a rock or anything. They're called man-made elements, synthetic elements. They were built, weren't they? They were made. So these are human-made elements. Probably the best or worst one is this one. That's called plutonium, and that can make it can be really nice if you use it the right way, or it can make one of the most deadly bombs. It's one of the most deadly poisons on the planet. If I had a little piece of uranium, I shouldn't say little, but a piece of plutonium this big, if I brought it in a room for 30 minutes, we would all be dead before the end of the day. You wouldn't even see why you got killed. But the amount of radiation that it gives off, it would kill us all. You get sicker and sicker that day, and you would never get better, and you'd have radiation poisoning. So we made some of these, and yes, that also makes a tremendous bomb. You can make a very, very powerful bomb out of plutonium. So we learned how to make new elements, but then we have to learn what can you do with them, like that. Right now we're up to about 118, and again, there might be some people saying, well, what can we do with these, you know? Well, maybe element 120 is going to be some super element that changes the world. I don't know. We don't know that. Okay. Well, anyway, so what's the opposite of synthesis is to break things down, and that's called what? What's that word? What kind of a reaction is this? AB breaks down into A and B. What's that called? That's right. Now, I'll even tell you that the test you're going to take next Friday, the very first page is about 12 vocabulary words. Can you think about some vocabulary words that would be on there? And I probably won't put a test bank on there because these words you should know. Do you think it's possible I might put chemical symbol? That could be one. Chemical formula, chemical equation, yeah. How about reactants? Oh yeah, that's probably going to be on there. Products, yeah. How about AQ? You think that might be on there? Oh yeah. What about coefficients? Coefficients might be on there. How about diatomic elements? Okay, let's go another. How about all these? How about all these? They could be on there, couldn't they? So really, you said, hey, you know what? I'm going to do okay on the first 12 questions on the test because it's vocabulary. There's no way. I'm going to say these words all the time this week, next week. All right, so decomposition. Let's take a look and see if there are any decompositions down here. And it just so happens that this page did not have any. So we flip it over. And I don't know who answered this yesterday, but there's always a giveaway. The giveaway on decomposition is how many reactants do you see? Leda, how many reactants are you going to have in a decomposition reaction?
2.
Say it again.
2.
1?
2.
1?
1.
That's right. Anyway, so if it's a decomposition reaction, you only have one reactant. You get it? That's kind of a giveaway, isn't it? Let's look down here. Another decomposition was this one. Man, this thing really decomposed. Look, it went from this great big old thing down to this and this and this. Man, it really decomposed, didn't it? Okay, and I think we had one more, number 9. And look at this right here. There's a giveaway. See how this thing breaks down into this and this? Oh, yeah. So I think you got decomposition now, don't you? Let's look for another one. Let's do another kind. This one's a little more difficult. Just a little more difficult, not a lot. Can you help me close that door, please? Thank you. God. Yeah, right. Okay. Okay. Dave. Okay. Oh, that's on video. Oh, well. Well, let's go to the next one. The next one's a little more difficult because it says here, A plus BC yields AC and B. What's that? Well, look what happened here. This element kicked the first part of this compound out, didn't he? How do I know he kicked him out? Because look, he's by himself. And A says, I'm going to form a compound with the second part of you. Get it? Everybody get that? And that's called single replacement. Now, yesterday, and again, I can't remember, I called on lots of people, but number 5, somebody correctly did that. Anybody know who did that? Who correctly answered? You did. Okay. Look at number 5. What is zinc going to do? Zinc is going to kick hydrogen out. How do you know? There he is. Look. He's not combined with anything else, is he? So zinc kicks hydrogen out, and zinc says, I am going to form a compound with chlorine. And here's the biggest mistake that people do in first year chemistry. They said, oh, I get it. It's cut and paste. You simply cut and paste the zinc and have ZnCl. Why did I just do a whole chapter on how to write formulas? How does zinc form a compound with chlorine? You go like this. Zinc is an always metal +2. Chlorine is -1. I had to have 2 chlorines to make this compound. Is that correct? Okay, now I know it bothers you, but we're going to balance it. We're going to balance it later. But right now, that's how you make zinc chloride. And then why did I write H2? Why didn't I write H? Let me see if Aurora's paying attention. Aurora, why did I write H2 instead of H? Yeah, why didn't I, if H got kicked out, why didn't I just write H? Why would I write H2?
Because it needs to be balanced.
No, I'm going to balance it with coefficients, but what made me write H2? These are called subscripts. Subscripts are the little tiny number. And I know it's not the easiest question, but I'll give you a clue. It has something to do with what Kyle said. It has something to do with the question that Kyle answered.
What question did Kyle answer?
Kyle, can you tell her what you just got done talking about? Diatomic elements. See, if hydrogen is going to be by itself, it's not going to be H, it's going to be H2, isn't it? It's a diatomic element. Is that correct? Okay, now let's go to the next page. See if you can find a single replacement. See if there are any single replacements here. Raise your hand. Yeah, Daniel got one?
Number 3.
All right, let's look at 3. Now, here's, can everybody look up here? I'm going to show you something. A, B, see the hydroxides like this? AB plus what? CD. So see, single replacement would be like A plus BC. So this is going to be a double replacement, so I'm going to say no for number 3. Let's go to another one. Layla.
Number 10.
Which one?
Number 10.
Let's go to 10. Now here I have A plus BC, and who's going to kick out who? Is magnesium going to kick out H or Cl? And in a compound, in an ionic compound, who's always written first? Like table salt, is it NaCl or ClNa? What's table salt? NaCl or ClNa? Because in ionic compounds, the plus thing's always written first, and the metals are the plus things, aren't they? So if this guy is going to kick out, who did he kick out? Layla, who did he kick out? He did. He kicked out H, so we're going to write magnesium chloride. Now, last chapter, how do you write magnesium chloride? Look up here. Magnesium is +2, is that right? What's chlorine? -1, that's why you had to have 2. See that? So I haven't balanced anything yet. I just make sure I write the formulas correct. Is there another one? Another single, Madison? Let's look at 8. Madison, who is iron kicking out? Yes, look, copper got kicked out, and so metals like to kick out metals, don't they? And then this right here is going to form iron 2 chloride. And there we go. And, okay, that's it. So this is also single replacement. There we go. Okay, what do you think? Now, we only have 2 more to go. And let's go back to our screen down here. And this one is kind of like single replacement, except a double. Now, look at this right here. AB, and by the way, I made a mistake. Even though someone else typed it, yes, she was a valedictorian, but she still made a mistake. But Summer Rogers typed this for me, and she made a mistake here. AB plus, she should have said CD. So if you'll change that right now, I need to change that for, I should have changed it before I printed it. AB plus CD. Can everybody get that? Now, who's going to change places here? A is going to kick out C, but C is going to kick out A. It's not one person being kicked out, it's 2. So they kind of trade places. Now watch. What would happen if A and C trade places? What would you end up getting? Say, get out of here. No, you get out of here. No, you get out. Tell me the compounds that would form. A's kicking C out. A says, I want to form a compound with D. If that's correct, AD. What would the other one be? What would the other compound be? CB, wouldn't it? See that? Now that's called double replacement. So let's take a look on this page. Do you see any double replacement reactions? Sierra. Number 1, watch now. A and nitrates like this, isn't it? Isn't this polyatomic ion like this? AB plus CD. There we go. Okay, ready? Sierra. Who is silver going to kick out? What's it called? Potassium. Is that right? But who's potassium going to kick out? Silver. All right, so what's going to happen? Silver is going to form a compound with chlorine. There we go. And potassium is going to form a compound with nitrate. Now, be careful. Be careful. It's a coincidence. This was +1 and this was -1, wasn't it? So when you make silver form a compound with chlorine, +1, -1. It's a coincidence that you don't have to change anything. You get that? And what about KNO3? Potassium's +1, nitrate's -1. See that? Even though it looks like cut and paste, it's just a coincidence that they were all +1s and -1s, okay? All right, let's do the next one. What do you think the next one is? Now, Julie, you weren't here. But let's see if you can do it. Do you think the second one, how would you classify the second one? And I'm going to show you a little trick, okay? Can I show you a trick? What now?
Sorry.
I'm going to show you a trick, okay? Can I show you a trick? Here's trick number 1. Trick number 1, when you're trying to classify or balance equations, whenever you see a hydroxide on one side of the arrow and you see water on the other side of the arrow, if you'll write the water as HOH, watch what happens now. Now, what does it look like? Now, what kind of reaction does it look like? And even though you weren't here yesterday, we didn't talk about this yesterday. No, not combustion. We haven't talked about that yet. So that would be unfair for me to give you a combustion one. Delaney, what do you think? Watch now. A, B plus C, D. That's right. Double replacement. See that? Now, Delaney, who is kicking out who? But who's sodium kicking out? Yes. So hydrogen wants to form a compound with OH, doesn't it? And HOH is water, isn't it? And what's the other compound going to be? What is it? Sodium is going to be NaCl or ClNa? NaCl. Everybody get that? And Na is +1, chlorine is -1. That's why it's that way. Yes, go ahead. Yeah. What do you think? All right, let's skip this one for right now. Let's go down to number 8. All right, let's see if you can, this is a tricky one. See if you can classify number 8. See if you can classify number 8. Can you do it?
I think.
Let's try it. Aurora,
Would that be single replacement?
say it again.
Single replacement?
You're right. Now, how did you do that? Because it doesn't look exactly like that. How'd you know that?
I just said that sodium was A, and then hydrogen and oxygen were B and C.
Okay. And
sludge is salt.
okay, so watch right here. Do you see where it's a hydroxide on one side of the arrow and water's on the other side of the arrow? I want to rewrite water as HOH. I don't always rewrite water. I rewrite water when there's an OH on one side and water in the other. Now look what happens. Aurora, help me out with this. So sodium, who's sodium going to kick out? H, or is it going to kick out OH?
H.
That's right. Look, he got kicked out, didn't he? And sodium says, I'm going to form a compound with OH. And sodium is +1, and OH is -1, isn't it? Yes.
So in single replacement, there's like always an element by itself.
Yes. Excellent. See, I love that because that means you're learning something. You're thinking about it. You get it? I know you could all come in here. You just write when I write. I don't want you to do that. Why don't you write before I write? Why don't you try and explore? I like that, what you just did. She said, if it's single replacement, isn't there always going to kick a single element by itself at the end? One of the products is going to be an element, isn't it? That's a great discovery. All right, now, this is going to be a hard one, okay? This is where we get a little more difficult. I'm going to tell you that number 9 is single replacement. I'm going to tell you it's single replacement. You have to finish it. Finish the equation. A little bit harder. You can do it, though. All right, give yourself about a minute. This is going to be the hardest one you've done all day. I tell you that it's single replacement. So now, what are the products going to be? And if you can do this right now, you're way ahead of the game. If you can do this right, you understand a lot. Try it. You got to try it. I got to write something down. You got it done? Ooh. All right. What's the answer?
I don't know if it's right, but I said aluminum and then SO4 plus C.
What do you think? You like that? You don't like that? You like a lot of it? You like part of it?
Yeah.
Do you like part of it? They like part of it. Okay. Do you like part of it? What part do you not like, Madison?
It's not when the compound's not like balanced, it's not 0.
And even though I don't use the word balance for formulas, but the formula is not written correctly, is it? Now, do you remember in a compound what charge is aluminum? Do you remember that? Remember, this is +1, +2. And remember silver, zinc, aluminum? +1, +2, +3? Okay, so what's the charge of aluminum? Let's put a +3 here, ready? Now, do you remember sulfate? You know how we spent time with polyatomic ions? What's sulfate?
I think it's -2.
-2, it is. Now, Julia, going back to you. That can't be a compound because he's +3 and he's -2. What are you going to do about it? What are you going to do about it last chapter? How do you fix this to make it a real formula? I'm +3 and you're -2. How do we fix that? All right, Delaney.
Why don't you put sulfate in parentheses and then put a 3 after it?
A what after it?
A 3.
A 3, yes. Because the smallest number these two go into is 6, right? So 2 times 3 is +6, and 3 times -2 is -6, and now we have ourselves a compound, don't we? So how do you write aluminum sulfate? Al2, SO4, taken 3 times. Everybody get that? Again, it's not cut and paste. It's not cut and paste. Now, Julie, you're going to leave this like that, or is it going to be Cu2? Okay, why is that? Ask, would you ask Kyle whether or not copper is a diatomic element? But he's an expert on that. Is that one of the, she wants to know if that's one of the diatomic elements. She says no. Why did you say it was a diatomic element? Okay. See that? So we're thinking, aren't we? We're thinking. All right, now, I haven't even started to balance. You get that? We're going to balance in just a minute. We're going to balance in a minute, but we don't know how to write these. Now, let me give you one more hard one. Look at number 10. Hydrogen gas reacts with oxygen gas to produce water. It's going to be a hard one. See if you can do it. Hydrogen gas reacts with oxygen gas to produce water. See if you can write that equation out. Are you already done?
No, can you say
Oh,
it?
what now?
Can you say it again?
Say it one more time.
Can you say it again?
You want to tell it to me? I'm not hearing very well.
Can you say like the?
Oh, it's right here. So, number 10, hydrogen gas reacts with oxygen gas to produce water. All right, everybody try it. We have till next Friday. We're going to be experts by next Friday. Now, let me write it as if somebody who wasn't paying attention. You said, whoa, that's what I wrote. Okay. H plus O. If you're not paying attention, you would write that. What do you think? What's wrong with that? Kyle, what? You know. Kyle knows what's wrong with it. What's wrong with this, Kyle? Hang on just a minute. Sierra, what do you think? Which one? What? Is that one of these are diatomic elements? Oh, okay. So when you have hydrogen by itself, it has to be H2, doesn't it? And what about oxygen by itself? See that? Okay, everybody got that? All right. Now, I have one more. I have one more category, and then I'm going to show you how to balance equations. That's kind of fun. Some of you are going to enjoy balancing equations because it's kind of like a puzzle. It's a puzzle with numbers, and I think some of you are going to really enjoy balancing equations, but not until we do the last one. The last one's called a combustion reaction. Now, to become these club, if you want to become a member of this club or this club or this and this one, that wasn't so hard. This is the hardest club to belong to. Number one, you must have at least carbon and hydrogen as one of your reactants. Number two, you have to burn it. And in chemistry, what does it mean when you burn something in chemistry? It means you combine it with oxygen. If I want to burn metal, I have to combine it with oxygen. You get it? So number three, if you want to belong to the combustion club, you must produce the following products: carbon dioxide and water. If you make carbon dioxide and water, if you have this, this, and this, you are a combustion reaction. When you did the candle lab at the beginning of the year, candles are made of C and H. And what did you do with your candle? And it might have been C25, H52, but they were made of C and H. And what did you do with your candle? What did you do with it? You burned it. What does that mean in chemistry? You let it combine with oxygen from the air. And what were the products? And you don't see CO2, do you? Some of you did something kind of neat. Some of you put a beaker over the top of a candle and you saw all kind of fogginess. What was the fogginess on the inside of the beaker? What's fogginess? Water. That candle was producing water. That candle was producing carbon dioxide, but I couldn't see the carbon dioxide. You get it? All right, that was a combustion reaction, wasn't it? The candle was a combustion reaction. All right, so let's go over here. And look at this right here. This has at least carbon and hydrogen in it. Yes. It's being burned, yes, and the products are carbon dioxide and water. So I'm going to put you in the combustion club. Okay, everybody got that? Now again, we're going to balance these in a minute. I'm just trying to classify them right now. What's right here? Look, carbon, hydrogen. I'm going to burn it. This is combustion. Except I need to put something over here. What's missing? Let me ask Zach, what goes on the right side of the arrow? If I tell you it is combustion, what has to go over here?
CO2.
Say it again.
CO2.
And there are two products. What's the other one? Look up there. If you're a combustion reaction, the products are carbon dioxide and yes. Everybody get that? Okay. Let's go ahead and flip it over, and I'll give you a minute to finish the other two. See if you can classify the other, not a minute, 30 seconds. How about 30 seconds? Classify number 3 and number 5. Now, if you forgot my trick on number 3, do you see a hydroxide on the left and a water on the right? If you'll do this, I bet it'll make it a lot easier to classify. Yes? All right. Layla, what do you got for number 3 and what do you have for number 5?
I said double replacement.
What about 5?
Double replacement.
You're right. Both of these are double replacement. Okay. Do you feel pretty good about classifying? Okay, so what's going to happen is, I'm helping you do your homework, aren't I? This is your homework sheet. Not right now, but when you go home and you're reading the chapter, but when you go home and you said, I don't have any homework. Yeah, you do. You take this home with you, and I want you to try to classify these, see? Try to classify these. All right, now the next skill, and I think this is a fun skill, okay? I have 5 tricks. I have 5 tricks that I can teach you to tell you how do you balance an equation. Now, number 1, when you balance, not number 1, but when you balance an equation, you must only use coefficients. I've already taken care of my formulas. I have to make sure that my formulas are correct. If my formulas are correct, I can only use coefficients to balance an equation, okay? You can't change H2O into H3O to balance. You can't do that. Water is H2O, isn't it? So right now, all of my formulas are correct. Now, what am I going to do to balance it? Coefficients. So trick number 1. Trick number 1 is called the odd-even mismatch. Now, I hope you guys, this is actually kind of the fun part, okay? The fun part is, can you learn how to balance equations? And that's a neat little skill to have, right? All right, I'm going to show you, my best one is number 6. We'll go number 6, please. Now, if I have to balance an equation, do you think this is already balanced? And by the way, I should write this to you. I'll put a little star here. When you're taking a test or a quiz, if it's already balanced, you don't have to add any coefficients. You get that? You must write the word balance, because then I know you didn't skip the problem. I said you saw it, and you figured out it was already balanced, okay? And I'll show you one of those in just a minute. Oh, okay, there you go. As a matter of fact, I'll show you one right now. Ready? On the left side of the arrow, I see 1 silver. On the right side of the arrow, I see 1 silver. That's balanced. On the left side of the arrow, I see 1 nitrate. On the right side, I see 1 nitrate. On the left side, I see 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. Oh, it's already balanced. So what do I have to write? It's already balanced. Got it? Now let's go down to number 6, though, because I like this number trick. Is this one already balanced? How do you know? I don't know. Well, let's take a look. On the left side, I had 1 phosphorus. On the right side, I had how many? It's already not balanced, right? Now, it is trial and error. That's why I sometimes use a pencil to balance equations. But take a look what I got here. I'm going to scan and say, whoa. Now, I could do this. I could too and start putting a 2 here. I could. But I'm going to try something different. I noticed this O2 here, but O3 here. Do you notice that? Will an even number ever balance an odd number? No. So here's my little trick. What's the smallest number? Oh, that's a 5, sorry. What's the smallest number at 2 and 5 both go into evenly? What's the smallest number that 2 and 5 go into evenly? 10. What times 2 is 10? Isn't that right? At 5. And what times 5 is 10? I guess I didn't hear that right, but did he say 10? Okay. What's so funny? Oh, okay, I missed it. Okay, that's all right. All right, so let's take a look here. Watch now. Now, one more time. Here was O2 and here was O5. And they'll never balance, but the smallest number they both go into evenly is 10, isn't it? So it's almost like putting a 5 there and a 2 there. Got it? Now, watch what I'm doing now. You gotta watch. 5 times 2 is 10 oxygens on the left. Let's go to the right side of the arrow. 2 times 5 is 10 oxygens. They're balanced. Phosphorus. 2 times 2 is 4. You only have 1 here. What are you going to do? What's everybody going to do? Wait, what are you going to do here? My oxygens are balanced, but my phosphorus, I don't. I have 4 here and only 1 here. What are you going to do? Say it again. A what? A what? What are you going to put there?
4.
Okay, that's what I thought you said. Anyway, you don't want 4 because what's 2 times 2? I need 4 phosphorus, and there it is. Now, because balancing equations is kind of trial and error, please look at me. Because it's trial and error, you always scan to see if you could have reduced it. Remember how your math teacher is always saying, can you reduce it? And can I reduce this? Can I divide this by all of them by the same number and keep the same ratio? No. I'm done. This was done. See, I'm done. You're balanced. Got it? Okay, let's try another. So trick number 1 is the odd even mismatch. Now, if you'll flip this over, there's one like it. Number 1 is an odd even mismatch. I want you to balance number 1 on this side here. Okay, balance equation number 1 is an odd even mismatch. It's like a little puzzle, okay? Some of you are going to be really good at this. Some of you are going to like the numbers part of this. Now, you don't need to look at the periodic table. There's no reason to look at the periodic table. Scan that thing. Everybody see it? All right. Who wants to show off a little bit? Let's show off. All right. Go. When I scan this, what's the first thing you noticed? Right, so you had 2 lumens here and only 1 here, and then you had 2 here and 3 here, right?
Yeah.
So there's the odd even mismatch, right? So how do you fix an odd even mismatch?
I put 3 in front of aluminum.
Well, don't tell me about it. Let's do oxygen first. How about that?
I put 2 in front of oxygen.
Okay, what did you put in front of it?
What?
What did you put in front of oxygen?
2?
2?
Yeah.
What did you put in front of it?
3.
What's the smallest number that 2 and 3 go into evenly?
Can you say
What's
it
this?
again?
What?
Say it again?
What's the smallest number that 2 and 3 to go into evenly?
6.
All right, what times 2 is 6?
3.
There you go. So to fix an odd even mismatch, it's almost like taking that number and making the coefficient, taking that number and make, see that? That will fix, now watch, how many oxygens over here, Aurora? You don't add, you multiply.
6.
6. How many oxygens here?
6.
That's it, they're balanced.
Okay.
Now do aluminums. How many?
2.
How many aluminums?
2.
How many?
2.
How many?
4.
Yes. So what is 2 times 2 is 4, isn't it? Isn't that right? So I have 4 aluminums on the right, but you only have 1 here. What are you going to put in front of that aluminum?
4.
That's right. Can you reduce this?
No.
No. I like that confidence. See? That's good. Yes.
How did you know that you're supposed to put a 2 in front of
Okay, because here. Okay, because what happened is when I scanned it, I saw O2 and O3, and my first trick was the odd even mismatch, wasn't it? How do you fix an odd even mismatch? The smallest number 2 and 3 go into is 6, right? So take 3 in front of that and 2 in front of that, and now I have 6 oxygens and 6 oxygens. Now, by putting a 2 here, that fixes the oxygen problem, but it also makes 4 aluminums, so I do that. All right, so trick number 1 is look for the odd even mismatches. We have 2 minutes. Okay, trick number 2. Oh, where's my trick side? There's trick number 2. All right, ready? Trick number 2. If the polyatomic ion ions stay as a polyatomic ion, try to balance them first. Okay, I want you to take a look at number, here we go. Go down to number 9 here, all right? Now, we're going to get better and better at this, okay? Watch this right here. Scan, scan, scan. Here's a polyatomic ion called sulfate. How many sulfates are there? Don't say 4. How many sulfates are right here? How many sulfates? 1. SO4 is what? Sulfate, right? 1 sulfate. How many sulfates over here? 3. So I have 3 sulfates here, only 1. Now I fix it. Now how many sulfates are there? 3. But how many coppers does that give you? 3. Let's put a 3 here. And what's the only element I haven't done yet? Aluminum. And how many aluminums do you have? 2. Only 1? I'll fix that. Now, can I reduce? No, I'm done. Here's what I'd like you to do for homework, okay? I would like you to this page and this page. I want you to take it home and say, if it's one of the tricks I showed you, try to balance it. If you said, I'm not sure how to balance that one, just wait. You wait till Monday, I'll show you 2 more tricks, 3 more maybe, okay? Hey, thank you very much, and I want you to do well.